This is kind of like part two, just the example section of this lesson. So I set this up previously. I said that we had angle B and we had side B, and I just decided we wanted to find side C. So we had this listed. I labeled them. This was at the end of the previous video, and I just wanted to find side C. So I used SOH-CAH-TOA, just the trig ratio, sine, because it uses opposite, and I have opposite. I have the number, and I'm wanting to find the hypotenuse. So sine uses opposite hypotenuse, so that's why I'm using sine, and this is the ratio it sets up. So to actually solve this, what we can do is we can say, well, this is a fraction over here, and I technically could have a fraction over here if I put a 1 under it. And then I use that nifty little cross multiplication product. So that's a nice handy tool to use using proportions. So I'll just cross multiply. 1 times 12 is 12. And sine of 25 times c is sine of 25 times c. And this is just basic algebra. We get really scared about this early on in trig because we're just not used to seeing this goofy thing. But it's a function, and when you have its input, it's gonna be a number, some decimal. So let's make sure we're in degrees. There's also radians, so you should contact me and I'll help you through that. But sine of 25 degrees is just some number, and then times by c. So we want to get c by itself. That's algebra, and the operation it's being applied to it is multiplication. So we would do the opposite, which is divide, or the inverse operation, which is divide. So we're just dividing by sine of 25. It would cancel on that side, and c would be equal to sine, or 12 divided by sine of 25. So I'm putting that in the calculator right now. 12 divided by sine of 25, and I'm in degrees, and I get c is equal to 28.4 units, and that's how long the hypotenuse is if everything else in this triangle is the measurements I gave it. And this is just units. In general rule, let's always just go to the tenths place unless it's specified other ways. We could use significant figures, but we'll just go tenths place for consistent practice. All right. So here's another setup. So you should pause it at this point and just try and see if you can set this up on your own, figure out what trig function you'd need to use, and then set up an equation, knowing that we're looking for side A. Okay, and you want to maybe go remember that we are using that acronym SOH-CAH-TOA. All right, so pause it and check that out. All right, hopefully you pause it, otherwise you didn't try. So here's angle A, 76. We know that side B is 13. And then we don't know angle B. We could find it out because 90 plus 76, and then plus angle B has to add up to 180. So we could subtract those two off of 180 and get B, but it's fine. We don't need it. And we're looking for side A. So this is the one we want. So based on A's perspective, we need to know the names of these sides in order to know which trig function to use. So the names of these sides, opposite A is A, side A, and that's opposite because it's opposite from the angle we're talking about. And then we always know that the long side's hypotenuse. So this is hypotenuse, and I can label it, but it's kind of irrelevant to us. We're not talking about it, and we don't have it, so we don't really care right now. And then the only one left over is adjacent. So we would have to know which one to use. We have 76, we have the opposite side, and we have the adjacent side. Those are the ones we're talking about. We only know the value of the adjacent side, but we have we're looking for the opposite side. So these are the two. We'd have opposite adjacent. That's tangent. It's TOA. So tangent of my angle. Also, sine, cosine, and tangent will always go with an angle. There's always an angle attached to it. Whether you know it or not, either it's a capital letter or it's a number that you know. In this case, we know it's 76. It is then opposite over adjacent, so A over 13. And there's a couple ways of thinking about this. One, if we're solving for A, we look at what's happening to A. It's being divided by 13. So I could just multiply both sides by 13 and be done with it. That's perfectly acceptable. I'm going to be consistent about the way that I talked about it in the last slide, in that these are fractions, and I can use a proportion. This is the same thing is going to happen. If I cross multiply, I get 1 times A is A, and I get tan 76 times 13. Again, if you prefer to recognize this as this is A divided by 13 and just multiply by 13 on both sides, that's great. I'm just trying to be consistent so we have one process. Tangent of 76, when you put this into a calculator, you maybe want to make sure that you close off a parenthesis if the calculator gives you a first parenthesis for your angle, and then multiply by 13. So that should give you tan 76 times 13. And I get A is equal to 52.1. All right, great. I have one more example here for this video. Here's another final basic example. This one throws a little bit of stuff in our way. We'll notice that when we start labeling our triangle or start figuring out what we got and what we're looking for, we see that B is 16 degrees and 45 minutes. We need to convert that really quick. So if you recall, we need to know what the decimal is. So we have 16 is the whole number, so that's 16 point. But we need to know 45 minutes. So basically you're thinking of this is as 16 hours and then 45 minutes. We want it all to be in terms of hours. Okay, it's really degrees, but we can think of it like that as a base 60 system. So we just want to know how many hours is 45 minutes. Well, 45 minutes, I want to change it to hours. You'd use a conversion factor. A lot of you have already figured out what that would be. It's 3/4, but you times it by, you want to change it to degrees, where hours, 1 hour is the same as 60 minutes. 60 is on the bottom because we want minutes units to cancel. And you'd get 45 times 1 is 45, divided by 60 is 0.75. But sometimes maybe it's not going to be that easy, so this is how you would go about doing that. That's from day 1 if you want to review that. Okay, so we got that. Now 16.75, that's angle B. And then we have side A is 13. Again, you want to label the triangle correctly because you need to know which sides are what to get what. And then we're looking for C. So we have to set up a trig function and then make an equation out of it. We have to know we're from angle B's perspective, and C is the hypotenuse. It's the easiest one to find right away. It's always the longest. It's always across from the 90. And then the other one we have is adjacent. I can tell that 2 ways. One, because opposite is the one opposite angle B. So that's opposite, and I'm not using it. That means that this is adjacent. So the trig function that uses adjacent and hypotenuse, because we have the adjacent, we have to use that. We're looking for the hypotenuse, so we have to use that. That's cosine. So the equation looks like cosine 16.75 equals adjacent, which is 13 over hypotenuse, and that's just C. And the consistent way that I've been doing this is I'm saying, well, this is a fraction, make that a fraction, and cross multiply. So I'd have 1 times 13 on one side, and cosine 16.75 times C on the other. It's a degree. And then we're trying to get c by itself. And it's being multiplied by this chunk. That chunk is just going to be some decimal. So like it looks crazy, and it's like, oh, I have letters over here too, but it's just it's a function of its own. It's going to give you a decimal if you calculated that. So c needs to be divided by what is multiplying it, and therefore we do the same thing to the other side. And then using a calculator, that will give us what we need. So 13 divided by cosine, and again, make sure you're in degrees. If you typed it incorrectly, you should get 13.6, I guess.